Hi guys! So today we'll be going over nuclear fission and the atomic bomb. Okay? So, this right here, this equation, is the equation for the nuclear bomb, basically. Right? So we have 235 uranium, 23592 uranium bombarded with 1 neutron, and it splits into 14056 barium and 9336 krypton and energy and 3 free neutrons. Okay? And how this looks is like this. So here we have the uranium, here we have the neutron. They go together and then it splits into energy, krypton, and barium. And there are free neutrons here, and free neutrons here, which react with the remaining uranium particles, because assuming you're not working with one atom, right? There's going to be multiple atoms of this uranium, and the free neutrons that result from the initial start bombardment reacts with the other uranium, and then it becomes a chain reaction, right? It keeps going, and this energy, it just is a self-amplifying chain reaction. And this can either be done fast in the event of a bomb or slowly for actual practical uses of energy, right? So the question is, we need 23592 uranium. That is uranium that is an isotope with 235 mass. Mass? Yes. And this makes up less than 1% of naturally occurring uranium. A uranium with a mass of 238 and 92 protons is more abundant. This is the most naturally occurring type of uranium. We don't get 235 uranium often. You have to make it. So how do you get 23592 uranium? We will need 92 protons and 143 neutrons. I got this number because 92 is the amount of protons of uranium to make uranium, and in case you forgot, the number of protons identifies the type of element you have. So once you have 93 protons, it's a different element. It's no longer uranium. Okay? And the neutrons, it doesn't matter how many neutrons you have, but in this case, for this reaction, for the atomic bomb, you need 143 neutrons in the nucleus. So what I figured out is that we can use a 259 isotope of nobelium with a amount of protons of 102 in the nucleus. So, nobelium has 102 protons and 157 neutrons in this 259 isotope. The goal is 92 protons and 143 neutrons. Now, how do we do this, right? We have processes called alpha and beta decay. Alpha decay is when you do -2 protons, you take away 2 protons, and you take away 2 neutrons. In beta decay, you add a proton and you get rid of a neutron and an electron. That is what's happening. And so to get from 102 to 92 protons, we need to get rid of 10 protons. And to get 157 neutrons to 143 neutrons, we need to get rid of 14 neutrons. Okay? So using this equation of alpha and beta decay, this is our starting point. This is what we're trying to do. Trying to get to 0, right? We can do 4 alpha decays, which is 4 times 2, right? 8 minus 8 from both sides. You get 2 protons and 6 neutrons. Now, then you can do 2 rounds of beta decay, which is adding 2 protons, right? 1 proton times 2, 1 neutron times 2. So you add 2 protons, subtract 2 neutrons. You get 4 protons and 4 neutrons. Now they're equal, which means you can do 2 rounds of alpha decay, which is 4 minus 4 protons and minus 4 neutrons, and that will get you to 0, which is what you need to get to 23592 uranium. Now, the question is, how do you get 259,102 nobelium? This is the most stable isotope of nobelium there is. Most transuranium elements are unstable, it seems, from what I know, from what I looked at least. But what I learned was that the bombardment of 23892 uranium, which is the normal uranium, the abundant one, with neutrons, causes decay of the uranium into neptunium. And this neptunium then also decays into plutonium. So you can use the abundant form of uranium to get to plutonium. And plutonium, let me just double check. Plutonium has 94 protons. And neptunium has 93 protons. Okay. So from here, how do you get from plutonium to nobelium? Protons of plutonium are 94 protons, and nobelium has 102, so we're off by 8 protons. I initially thought that we would just keep bombarding with neutrons until it just becomes nobelium. But apparently, there are equations that we can use. And the equations are, you use 239 over 94 plutonium plus 4 over 2 helium to get 242.96 curium and 1 neutron. And that curium is 96, has 96 protons. You take curium, 242 and 96 curium, and add 12.6 carbon, you get 254,102 nobelium and 4 extra neutrons. So this is where it gets kind of tricky. We got 254 1 over 102 nobelium, but we need 259. We need 259, so we're off by 5 neutrons in the nucleus of the nobelium, of this element. Possibilities, because I was looking for the answer, I couldn't figure it out, I'm just going to guess of how they do it. Possibly through particle accelerators and lots of energy and lots of money in order to achieve this number, this element, this atom, in order to get to 235 uranium. Now, you're probably wondering, how do you just add neutrons? Like, how do you split an atom, a nucleus, to get the neutrons, right? Like, where do you get free neutrons in order to start this decay process, this nuclear fission, the splitting of an atom into multiple facets, right? And this can be done with beryllium and helium, which turns into carbon and results in a free neutron. So that is my explanation on how, or at least the equation of what I believe leads or makes up a nuclear weapon. The key is 23592 uranium. This is the key. If you have that, you can make a bomb. The reason why I'm talking about this, like, why is this important, right, is because as it stands, the people in this world who have access to nuclear powers are they're just not doing the right thing, right? The nuclear powers, the nuclear countries are not acting the way that they should be. And my hypothesis is that if all the nations in the world had the recipe, or at least some help towards getting the recipe for a nuclear bomb, the countries in possession of nuclear bombs would lose their leverage and their standing, and finally be equal. It'll be equal grounds amongst all the nations in the world on this planet. So, what implications does that mean? That would mean Ukraine will no longer have to buy our weapons. They can just use the recipe and use that as leverage against Russia. It would also mean that surrounding nations around Palestine can have leverage against Israel, because Iran already has an abundant amount of normal 238.92 uranium. Right? They could implement this easy. Whether or not this is a good idea, the fact that nuclear weapons exist in the first place was never a good idea. So, why have this power play anymore? Why pretend as if we're powerful when all we have are empty threats against one another between all these nations? Right? If everyone had equal standing, then we'd actually be able to have a thorough conversation at the United Nations. This is why I'm doing this. I hope this helps. I hope I'm even close to being right. I'm no chemist. I'm not a physicist. I'm just using what I learned based off my chemistry textbook and the internet. So this is what I found out. And I feel like there's some benefit and merit in being raised in a country that has a nuclear weapon. So hints are around. There are a lot of hints. So hopefully this helps. Let me know what you guys think. Share this with your friends, family. Let them just have that conversation. What do you think? Do you think that we should continue to be a nuclear power? Do you think that we should share this knowledge with other nations that need help, such as Ukraine and Palestine? Right? Should we be equal with the rest of the world? Or should we keep being in this position that we're in right now? So yeah, that's all I have. This is my best shot for helping. Well, I'll just leave it at that. You guys have a blessed day. Bye.